Hello, my dear students. Welcome back to the lecture. I'm expecting that you have at least done certain calculations. Anyhow, we'll start with that. Okay. So, what is the calculation now? Now we are calculating this side. Okay. This side we have put the top extra bar. In this way, we have put it all throughout in this way. This is already done. That can be seen here. Okay. This is that one. And now we are supposed to find the distribution still. I mean, this distribution I'm supposed to find, isn't it? So first you find the cutting length. Tell me what will be the cutting length of this bar. It's very simple. 5525 I have here. 5125 I have. From there I'll deduct half the beam from here, half the beam from here, and in the middle portion I'll deduct one full beam. Okay. So this is the shape what I have drawn. I've done the same thing. See, 5525. This is 5525. Then 5125. This is 5125 minus 150. This is minus 150. This is minus 150. Middle portion I've deducted 300 because you know, right? This bar won't go through the beam. Practically it goes, but usually when calculating, actually it should come here. If you don't deduct also, nothing will happen. 300, 300 and doesn't make any sense. Okay, but that is this is the right way to do. Finish. This is done. Now you have to write distribution bar for one junction. Whatever you have written, no, same thing you write. Only the thing is it was top extra bar. Here it is a distribution bar. Okay, or you can write distribution bar, distribution top extra also you can write. Fine. Fine. After that, the important thing is to find the number of bar, right? How you will find the number of bar? It's very simple. Whatever is this orange color length from the face of the beam to here, that I need to consider. So that is already known to me. That is 1150. So 1150, I'll divide it by 150. So you do it manually. You add plus 1 to that. So how you will add? You will add plus 1 or you will add plus 2. So you'll be adding only plus 1, no? I think it should be plus 1 only. Yeah, it will be plus 1 only. Okay. Yeah. So it should come here. See, round up I have done. I'll show you what we have done. Round up, and this is 1150 divided by 150 and plus 1 because only one span. This continuous I'm taking one span. No, that is why. Finish. So when you do, it will come out to be number of bar is 9 number. So total cutting length is of course this one 10,050. Okay. So 10,050. Then you find the meter. It is 10.05. Total cutting length will be how much? 10.05 into number of bar into number of members, and then total weight. Total weight will be how much? 90.45 into unit weight is 0.617. Okay, that's it. Finish. Your answer is ready. You got this part. Now, whatever you got here, do you agree with me that whatever you got here, the same will be here also? Because here also you're going to put the top extra, no? Same you're going to put here. I'll put here, okay? And then your cutting length, of course, it remains the same. Whatever cutting length you had here, same cutting length you'll get because here also it will go from here to here. Here also it will go from here to here. Here also it will go from here to here. The same thing will happen. So cutting length, we don't have issue. Only the number of bar I'm supposed to find. That is also very simple. Number of bar you come here. This is also 1150. This is also 1150. So your answer remains the same. Come and check here. See, 10,050, 10,050. And distribution bar on junction 3. This is my junction 3. Okay. On grid A, B and C it is. So again, you see 150 number of bar I got 9. Previous also I got 9. Finish. So the cutting length, everything remains same. 55.808, 55.808. So if you're someone who was someone, I mean, say, since you're doing it for the first time, I don't recommend. But if you have work on multiple projects, then you check the dimension of both the bar. If it is same, then instead of doing it 2 times, no, you can just in the number of member, you make it 2. Finish. Your answer will be ready. Now here, since I'm explaining you, I'm just, separating out each and everything. But tomorrow, once you gain experience in the projects, you just have to see whether it is same. Then just multiply it by 2 and write this whatever you wrote, write it here also. Finish. It's understood that for the both of the span you're done and you're multiplied by 2. That's it. Finish. Your answer will be ready. But now we'll not do. We'll go with the same old method. Fine. After that, the last part what we have. The last part what we have is this one, right? Which is that this part. Here also your bar will come, no? Now this part. Okay. So this is a continuous slab. Continuous. Finish. You know that already how it has to be done. I won't explain you again. Okay. This distribution I'll find now. This side. So it will be plus 1 on this side. If I do here, it will be plus 2. So when I find the number of bar, it has to be plus 2. Okay. Same thing I've done. Again, the cutting length remains same. This length remains same. So directly I've written that. So I written distribution bar on grid number 2, laying in A, B and C. Okay. Along. Fine. So number of bar, you just see. How we'll find the number of bar? So this length I know. This length also I know. That is already given here. This is that 2600. But in that, whatever is a beam width, that is 300 I need to deduct. From 2600, I am deducting 300 here. Okay, getting my point? And then you divide it by spacing. Spacing is 150 and plus 2 has to be done. One span on this side, 1 plus 1 on this side, 1 plus 1 on this side. Finish. Your answer is ready. So in this way, okay, I haven't done the answer. How much it is? So it's a 10 diameter bar, no? Finish. Answer is ready. Multiply by 0.617. Finish. And why this is 144? From where did I write one? Why did I write 144 here? Okay, this was some previously we had done. Okay, this is not required. Finish. 111.615. Got it, no? So in this way, I've done for one complete set. Getting my point? In this way, I've done it for this portion. This portion, all the BBS is completed. Nothing is left. Similarly, I need to do on this side also. No, this side also I'm supposed to do. So what you do? I'll take that in the next lecture. So you try to do it. You know how it has to be done. In next one lecture, I'll finish it off in one lecture. Okay. And if I do this and then if I calculate, no, total BBS for my beam is done. One thing you have to remember, it's written first, second, and third floor slab top reinforcement. Right now we are doing for one. If you or you can do one more thing. You can write here the name of the sheet. Yeah, you can make here, right? It's for the ground floor, because you see here it is written for, I mean it is for the first floor. Then same thing you copy and paste another, and you say first second floor. Then again you copy and paste, again you say third floor. You can do that, no? That thing you have to do, but I'm explaining you for only one. Rest all things remains the same. That is why they are written first, second, and third. Otherwise, you can ask me, sir, we can do one more method. Yeah, in the number of member, you multiply it by 3. So you'll get for all first, second, and third floor. But what will happen? No, in few of the places we have multiplied this by 2. Okay, we haven't done that. No, yeah, that also can be done. Anyhow, last I'll do that. Not now. Now let everything be one only. Since we have 3 floor, we are doing it for the first floor, second floor, and third floor. Everything is same, and the number of member I'll multiply it by 3. In that way, for the entire first, second, and third floor, my B base is ready. Okay, fine. You practice up to here. In the next lecture, I'll go with the other part. So we'll see you back in the next lecture. Thank you.